So these are the notes for constant velocity on page 16 in your notes packet. We'll start with 3 questions, just to review how we can talk about how fast something is moving or where it is. So the first one, it asks, if you drive 60 miles in an hour, how fast are you going? And so the way that we describe speed is in miles per hour. And so we can take this distance that they traveled and divide it by the time that it took them to travel that distance to get 60 miles per hour. The second question, if you drive 60 miles in 2 hours, how fast were you driving? And so we'll follow a similar pattern to the first one, divide by 2, and so we'll get an answer of 30 miles per hour. And then the third question, it asks, if you drive at 20 miles per hour for 4 hours, how far did you go? And so what this tells us is that each hour you drive 20 miles, and so we have to repeat that 20 miles 4 times, or multiply them together to get a distance of 80 miles traveled. In your homework, you're going to see 3 variables, and so we're going to define those variables. The first one is velocity, which is the rate of change of position of an object. In similar terms, it tells you how fast you are going and the direction. So in your notes, you can copy this row of information. We symbolize velocity with the letter V. The formula to find velocity is displacement divided by time. And the units are meters per second usually. If a question asks you how fast is something going, those are keywords that tell you they're probably asking for the velocity of the object. Displacement is the change in position of an object. In similar terms, it is how far away an object is from the start, and it includes a direction. So we symbolize displacement with the letter D. In order to calculate the displacement, we can multiply the velocity of an object times the time that that object is traveling at that velocity. And the most common units for displacement are meters. If a question asks you how far did an object move, then it's probably asking you for the object's displacement. And the final variable is time. Time is pretty hard to define, but it is part of our equations, and so we wanted it to be part of these notes. So we symbolize it with the letter T. We can calculate it by taking the displacement of an object and dividing it by the velocity of that object. And usually we measure time in seconds. The words that a question would include if it was asking for time is how long. Like, how long did it take for this object to go here? So the first half of your homework, which is on pages 17 and 18, deals with the 3 formulas that we just wrote down, and you'll be calculating either velocities, displacements, or times based on certain problems. The second half of your homework will be calculating the velocity of an object from a graph. So to do that, what we need to find is the slope. So the slope of a position time graph is the velocity. You can write that on your notes in the blank lines. And then the way to calculate slope is to find 2 points on the line, write them as an ordered pair, and then use this formula in order to find the slope. So for example, in this position time graph here, we can find the slope of this red section of line by taking this point, which is at 5 seconds and 4 meters, and then this point, which is at 0 seconds and 1.5 meters, and then we can plug those values into the slope equation here. So you'll see that that second point is 5 seconds and 4 meters. The first point is 0 seconds and 1.5 meters. And so when we find the difference, when we find the run, we find 2.5 meters. The rise is 2.5 meters. The run is 5 seconds. And then we can divide those values to get a velocity of 0.5 meters per second in the first 5 seconds. Then we can also look at the second section of line. And so there our points are 5 seconds and 4 meters. and 10 seconds and 9 meters. And so when we use the same slope equation, we find that that has a slope of 1 meter per second, and therefore the velocity for the second half of this graph is 1 meter per second. Thank you for watching.